Hi, let us continue studying integral calculus. Now, for our fourth integration formula, we have here the trigonometric functions. The integral of cosine u du is equal to sine u plus c. The integral of sine u du is equal to negative cosine u plus c. The integral of secant squared u du is equal to tan u plus c. The integral of cosecant squared u du is equal to negative cotangent of u plus c. The integral of secant u tan u du is equal to secant u plus c. And finally, we have here the integral of cosecant u cotangent u du is equal to negative cosecant u plus c. Those are the formulas we're going to use in solving problem with trigonometric functions. Example number 1, we have here the integral of secant squared of 4x dx. The derivative of 4x is not just dx, it is 4 dx. Therefore, we need to place 4 in here and 1/4 outside the integral sign to compensate 4. Okay? So we have here 1/4 of the integral of secant squared of 4x 4 dx. The derivative now of 4x is 4 dx. Now we have here 1/4 of tangent 4x plus c. That is the integral of secant squared 4x dx. Next we have here the integral of cosine 1/2 y dy. The derivative of 1/2 y is not just dy but instead it is 1/2 dy. To compensate 1/2 here, we placed 2 before the integral sign. So we have here 2 integral of cosine of 1/2 y times 1/2 dy. And then we have here 2 sine of 1/2 y plus c. That is the integral of cosine 1/2 y dy. Let us continue. We have here the integral of secant squared of 3x dx divided by 1 plus tangent of 3x. Okay, so in here, we can see that tangent 3x has a derivative of secant squared of 3x 3 dx. Therefore, since the du of the denominator is in the numerator, then we may use here integral of natural logarithm or ln. So we have here 1/3 of the integral of secant squared of 3x 3 dx. Now we have 1 plus tangent 3x as our u, and the du of this is secant squared of 3x 3 dx. Therefore, we may use the ln rule. This is now equal to 1/3 of ln of the quantity 1 plus tangent 3x plus c. That is the integral of secant squared 3x dx divided by 1 plus tangent of 3x. Next, we have here the integral of cosine squared theta d theta divided by 1 minus sine theta. Okay, cosine squared theta has an identity of 1 minus sine squared theta. We have learned that in trigonometry. But 1 minus sine squared theta is also equal to 1 plus sine theta times 1 minus sine theta. Okay, we have here 1 minus sine theta on the numerator and we have here 1 minus sine theta on the denominator. We can cancel that. So what we have here now is the integral of the quantity 1 plus sine theta d theta. And the integral of d theta is theta. The integral of sine theta d theta is negative cosine theta. So finally, the answer is theta minus cosine theta plus c. That is the integral of cosine squared theta d theta divided by 1 minus sine theta. I hope you can follow. Let us continue. We have here the integral of sine theta d theta divided by cosine to the 4th of theta. We may put cosine to the 4th theta on our numerator. Then we have the integral of the quantity cosine theta raised to negative 4 sine theta d theta. the derivative of our u, which is cosine theta, is negative sine theta d theta. But we have here sine theta d theta. Okay? So, we need to place negative 1. That's why in here we have negative quantity of cosine theta raised to negative 4 plus 1, the power formula divided by negative 4 plus 1 plus c. And that becomes negative quantity of cosine theta, closed quantity, raised to negative 3 divided by negative 3 plus c. And finally, negative divided by negative is positive 1 over 3 cosine cube of theta plus c. That is the integral of sine theta d theta over cosine to the fourth theta. Next, we have here sine squared y dy divided by 1 plus cosine y. And sine squared y in trigonometry has an identity equivalent to 1 minus cosine squared of y. Okay? So, we may rewrite sine squared of y with 1 minus cosine squared of y. Okay? But 1 minus cosine squared of y is 1 minus cosine y times 1 plus cosine y. We have here 1 plus cosine y on the numerator, and we have here 1 plus cosine y in the denominator. We may cancel that. And then, what we have now here is the quantity, the integral of the quantity, 1 minus cosine of y, closed quantity dy. dy times 1 is dy, and the integral of dy is simply y. Negative cosine y times dy. The integral of negative cosine y dy is simply negative sine y. Finally, we have y minus sine y plus c. That is the integral of sine squared y dy divided by 1 plus cosine y. I hope you got it. Thank you.